Hi, and welcome to my talk today. This is in preps for the Data Science Online Camp that's coming up soon. My talk is Apache Pulsar for machine learning. I'm Tim Spann. I'm a developer advocate at Stream Native. And today I'm going to be talking about what is Pulsar, a little bit of the background, how to use Pulsar to do machine learning functions, show you a little demo, and cover a couple of things. I've been working with streaming and machine learning technologies for over 15 years, everything from Pulsar, Flink, Spark, NiFi, Big Data Cloud, Apache MXNet, IoT, Python, lots of cool stuff. Worked at Cloudera, Pivotal, Hortonworks, Ernst & Young, HPE, a bunch of different places. I've been emphasizing what I call the flippin' stack, which is Apache Flink, Apache Pulsar, and Apache NiFi together. These open source tools let you build any type of streaming application, from IoT to deep learning, logs, machine learning, anything you could think of that involves events, data, sensors, data you want to get quickly somewhere, then do it. And if you want to do batch, really batch is just a very slow stream, so you could do that too. Every week I've got a newsletter out in a couple different formats. Check it out. By default, it comes through LinkedIn. So if you use LinkedIn, it's really easy. If you don't like LinkedIn, I also have it in GitHub and Medium and a couple other places. I cover Flink, Pulsar, NiFi, Spark. Got videos, slides, code, examples, podcasts, machine learning, Python, Java, Spring, all types of fun stuff there. But let's get into Pulsar. It's been around for a couple of years. Got links to some things coming up here. Some of the main benefits, and these are very important when you're doing any kind of real machine learning apps that are, potentially going to scale out to millions of concurrent things going on. So we can run lots of different applications, companies, groups, business units, within one Pulsar cluster because of its multi-tenancy. Very scalable. There are companies out there running petabytes of data, as big as you need to go. You don't have to worry about hitting a limit. When Yahoo originally designed it, it was to scale to internet giant company scale. Geo-replication, so you can get your data anywhere in the world, any availability zone, any cloud, on-premise, wherever it needs to go, and without any heavy lifting, whether it's, you want full active replication between multiple sites, or it's just one active and a backup. Pretty easy to do with just some configuration. One place to do every kind of messaging, because we said you could have that one big multi-tenant cluster, and we'd support lots of different protocols, lots of different styles of messaging. We'll show you a little bit about why that's great for machine learning. And your data, we're going to make sure you don't lose it. And we're going to do whatever it takes to keep you from losing that data. Very durable place to put your data while it's in the events or forever. What's nice is you could adjust how durable, you want it to expire. You want it to be very short-lived. Maybe it's something coming off a device where you don't care about every message. So maybe you don't store that at all, except in memory for a short term. Whatever makes sense for your use case. Cloud native from the beginning, designed to scale out up and down very easily, handling messaging and event streaming. One platform for that. Yahoo created this back about 10 years ago. Then after a couple of years when they were doing really well with it, they put it out there in the open source to get more people to use it and to contribute. Made it all the way to the top of Apache as a top level project, 2018. And then now we've got a huge number of multiple protocols supported, like Kafka and AMQP, and lots of fun stuff there. Support for functions, millions of downloads, lots of contributors. Great project out there. And over time, it's just scaled out. It started off pretty small among all those different messaging and streaming libraries out there. Then over the years, as it's been out there and people started to see some of the benefits of having one thing that could do all these old style messaging, support for protocols like RabbitMQ and Kafka and MQTT, but also support modern things you expect in Kinesis and Kafka. We could do exactly once, in order, things like CDC. And in the last couple of years, now that there's, some professional companies, behind Pulsar, things have exploded. The number of pull requests out there, the number of people using it, extending it, adding new features. It is a very active, growing project, as you could see here, blowing away any other of the messaging systems out there, to the point now that it's, one of the biggest you'll see anywhere, which is pretty cool. Let's get out of there. As we mentioned, some of those really cool features, and those are all in the open source. You don't have to pay to get georeplication or multiple protocol support. That is out of the box. What's nice is you can support all those legacy apps that you have doing Rabbit and Kafka and MQTT. Do modern apps that you want, and get ready for those next generation as more things get added, like support for different protocols, new types of messaging with things like WebSockets, all in one place. Great way to do that. Again, you don't have to decide, am I using a messaging system? Am I using event streaming? Am I going to try to hack it so I could sort of get things working in just one? You don't have to worry about that. Pulsar does both of those natively without a problem, and you are not the only one using it. Lots of users out there. Very growing project. And to answer some of those questions I know that are coming up, yes, it is similar to Kafka, but basically it's the next Kafka, a superset of Kafka, because we have support for queuing. We've been designed from the beginning to be cloud native, so we have stateless brokers. So when I extend out my cluster or shrink it down based on workloads, I do not have to worry that all those brokers are tied to massive data stores like in Kafka. So that's a nice feature to be able to easily do things like add nodes on the fly. We got support. We don't have to worry about manually rebalancing brokers or clusters. And again, geo-replication, multi-tenancy, end-to-end security, SSL, everything out of the box. No proprietary APIs there. Nothing that's locked into a vendor. Use the open source, get all the features. Plus extremely low latency, very fast, very easy to scale up or out. Partitioning rebalance is automatic for you. You don't have to worry about downtime. Very easy to subscribe to data any way that meets your use case. And built-in compatibility with all those things you have already, so you don't have to worry about it. The way we do this is separating compute and storage. So Pulsar brokers do the routing, make sure your messages connect. There's a little cache in there, but it's stateless. Automatically load balance where things need to go. Topics are made of multiple segments so they can be moved around, and you don't have to worry about if a broker goes down. We store everything in a real data store, Apache Bookkeeper. Again, keeping that isolated so we can scale out easier. This stores the messages and cursors, so in case, consumer goes away, you don't have to worry about losing where you were. Things are segmented into ledgers so they can be stored out on multiple servers, multiple disks, like you've seen in the old style Hadoop. This makes it more durable and a better option for when you're writing lots of data. We keep our metadata and service discovery separate in a metadata storage layer. That could be traditional Apache Zookeeper or people in Kubernetes, etcd or RocksDB. This is an open API, more being added there. And it's pretty straightforward to have that. Yes, having 3 nodes might seem complex, but it isn't. They don't really, outside of the Pulsar broker, they are very minimal upkeep, very easy to run, don't need too many of those nodes, and things like etcd are just part of your Kubernetes environment. Again, Kafka and Pulsar, have a lot of the same features, but there's a couple in Pulsar that give it some of that next generation feel. Things like message retention based on acknowledgement, so you can keep messages for as long as you need to until someone consumes them with their subscription and says, yes, I received that, acknowledge it. So you could skip some and go back and go, hey, I'm not going to throw this away because it hasn't been acknowledged yet. So you don't lose messages or skip them. You can go back. Built-in tiered storage. So, you get to a certain size and you go, hey, I can't afford SSDs. Okay, we'll put as little as you can in Bookkeeper, and then when it hits a certain size or time, whatever you decide there, have that automatically tier out to something like S3 or HDFS or, wherever you want to put it. And then have that automatically be accessible to anyone who's consuming that message with Pulsar. You don't have to manually write something to bring that back into primary storage or copy it around. It's just available. Round robin queuing, key-based queuing, a dead letter queue. This feature is very nice. Being able to schedule messages to come later, delay them for a certain period of time or for waiting for something to happen. This is great so you don't, if something needs to come later, you don't have to add some other mechanism for that. Very nice. High availability of writes because it's a real data store. So you could have multiple nodes go down because we're striping that. You lose a node, not the end of the world. Very easy for things to scale out. You don't have to manually rebalance things. Very easy for that elasticity. And support for a lot of topics. Again, something necessary if you're going to have only one messaging system. So support for millions of topics is not only theoretical. There are people doing that in production for some really large users of Pulsar in China and some other parts of the world where they have massive amounts of data into the petabytes, millions of messages, thousands of nodes, not a problem. And remember, millions of topics, and you have that multi-tenancy. So I have tenants, namespaces, and topics. So don't imagine you have 1 million topics. You do a list of topics, you're seeing a million. You could segment these up, create them in a hierarchy, give security so people could only see certain parts. Again, that multi-tenancy, very nice feature to have there. Everything is a message. So this is important when you're doing your machine learning. Get the thing that you want to operate on as your value. By default, it's raw bytes, but it could be strings, it could be JSON, it could be protobuf, it could be Avro, whatever you need there. And we could have a data schema, make sure that that's consistent. So you can have a contract for your data to who's consuming it and producing. Very important. Put a key on there so you know what it is. Good for instant access, good for partitioning, good for debugging. Put a key on there. There's a lot of good value for that. We've got some advanced features that make that really cool. Properties, this might be where you want to write some of that machine learning metadata, or maybe in the results of your machine learning on that payload, and I'll show you that. Give your producer a name so I know who made this data. Again, for debugging, just for your own auditing purposes. We'll give you a sequence ID so we can make your messages in order if you need that. So the way we do the magic of different types of messaging is having subscriptions. What that means is when you're consuming the data, you have to decide how you want to consume it. What that means in practice is whoever's pushing the data in the system, it doesn't matter. However I get it in, whatever protocol, whatever style, I can consume it in different ways. So I could use that same data for different types of apps. So a Rabbit app, a Kafka app, a Pulsar app, an MQTT app, a WebSocket app, machine learning, Spark, Trino, Flink, NiFi, Pinot can all use the same data in different styles concurrently if they need to. So I could decide in one app that I want to be an exclusive consumer, give myself a name subscription, and consume it exclusively. Only I get it. I get it guaranteed order. I'm the only consumer. Great, Kafka style, enjoy. Now you may want to go, what happens if that guy takes a nap? That app goes away, it dies. Well, let's use failover. It's the same exclusive subscription, but we have a backup set up. If the first person goes down, let me use the other one. Nice. Now, what if you want to do messaging? We mentioned Rabbit style messaging. Do shared. Everybody can consume it. They get their own messages. No particular order. But if I want to do a work queue or get a lot of data processed right away, great way to do that. Again, a great way to distribute a workload. Say I've got a lot of data that I've got to analyze, maybe send it out there because I'm doing training. Multiplex that out. Boom. Great way to do that. Now, maybe you want to split the difference. I like that shared. I want a lot of people consuming it, but I want things in order. So I can give it a key, and then I can be in order for that key. Again, the importance of a key. Now, this use case for me, the most common is CDC. I've got a whole bunch of tables in there, and when they change, I want them to be processed concurrently. So I can make the table name the key, and then have a consumer going for each key. Boom, concurrent access to that. Really great way to do that with only one cluster. I don't need 50 clusters running somewhere. Everyone can have their own tenant or namespace. Key separated out. Boom, very nice way to do that. And that is an awesome feature there. Again, one place to do every kind of model. All those features you need, any size. Again, messaging and streaming aren't the same. I know there's a lot of overlap, and there's some, thinking that very often messaging and streaming seem the same. But there are differences, like streaming use case common is something like move a lot of data somewhere to somewhere else, logs to Elasticsearch. Maybe you're moving, big chunk of data from on-premise to the cloud. Maybe I want to do a cool one I like is real-time analytics, something I do in Flink. Compute as close to real-time as I can, an aggregate of messages over a stream, and be able to scale that up. So I might need, hundreds of server nodes to process this because it could be billions of events a second, petabytes of data, something you want to be able to scale out. That's a streaming use case. Sending a message on a schedule, like notifications, instead of having to do something like pull it off a queue or pull it out of, Kinesis or Kafka and then put it into some other system that could schedule something out. I could do the scheduling with messaging within Pulsar, which is nice. Distributed work queues. Do this as sort of an RPC. Send a command from this service to another one. Boom, messaging. Again, not the same. Very hard to think of them completely different, but they are different uses there most commonly. Now, how long do you want to keep this data? In messaging, tend not to keep it that long because I used it to do something. That's it. Maybe I'll replay it. Probably won't. Again, maybe I'll keep that for a day or two. Throughput, kind of consistent. They're not going to have a big rerun of data. So it's very consistent, maybe not a lot of throughput there. Streaming, I might want to keep a ton of data, maybe keep it forever because I may need to rebuild systems, put it somewhere else, or just use Pulsar as my source of data for running analytics in Flink or Pinot or somewhere else. Great way to have it there and just keep it as long as you can. Again, with that tiered storage, not super expensive. And again, very often I might need to catch up, so I might need to go back, rerun things. Another reason to keep that data longer. Now, there's an interface within Pulsar to make it really easy to get that old data. Using the reader interface, I can read the earliest message ever. Again, if you retain your messages forever, even if it's in tiered storage, I could use this to go to the first one ever. Or I could go look at the most current. And again, I could also look at ones that haven't been read yet. And I could do that because we have that ability to acknowledge individual messages and we keep cursors to track where you are. You can move through it. You can also store the those IDs somewhere and be able to go back there again for auditing or whatever purposes you have. Maybe I'm keeping them somewhere, maybe even keeping them with the database and go, hey, let me confirm this against Pulsar or rerun something. Gives it really good flexibility there. Remember I said you want a key? Well, if you keep a key, I could use the new table view. This is in the newer versions of Pulsar. This lets me keep a current key value map of the data as it comes in, and this is updated. So if I get a new value for that key, it's going to update it and have it available as this very fast read-only little table I can access. A common use case that my friend David has come up with is for stocks. What's the current value of the stock based on that ticker? Great way to do that. Very simple. I don't need to have another key value database or something, or store that in some RAM within my app. Pulsar will handle that for you. Very nice. Again, I mentioned it's raw bytes. Obviously, raw bytes aren't everyone's favorite way to work with data. So you're probably going to want to put in some kind of formatted structured data or semi-structured. We got you covered there with a schema registry. We can have a schema connected to that data, and it's the most popular ones. And this, again, is an open API. You need to add more. But Avro, Protobuf, JSON are pretty common. So what's nice is first time you're going to send data to a topic, you don't have to pre-build a schema out there, which you could if you have schemas somewhere else or you have a very strict policy of how you control your data governance. Yeah, maybe create the schema in some master system, send that downstream here. But another way is create like a Java Bean or a Python class, send that with as your record of data coming in, specify that you're going to use a schema. Then the first time it comes in, it will upload that schema to the internal schema registry in Pulsar, and that will be used when someone consumes it. And if you change it, it will put a new version up there for you. It is really nice. You just have to deal with data and data in your app, and you don't have to think of what is a schema, how do I store it, how do I access it. It's just part of the SDKs out there for you, so you don't have to do much heavy lifting. What's nice is if I specify a schema, that schema will be acknowledged by Flink, by Spark, by Trino Presto, and by any consumers that are using the proper SDKs out there for Pulsar. Really nice win-win for everybody. So why do I use schemas? I commonly use JSON data and JSON schemas because everyone knows them. They're human readable. You know, it's a nice, consistent format. Maybe it's a little verbose and a little chunky, but I'm usually using that for smaller events. If you're worried about that, you can always add compression. If that's still not enough, yeah, switch to Avro. Again, especially if your downstream systems support Avro, might be a way to go. So we'll keep things consistent, keep a contract of that data, keep the data clean. As we mentioned, all the streaming SQL tools will access that. Win-win for you. Use a schema, use a key, use some kind of format like JSON or Avro. Makes everything useful and easy. Again, JSON's a really easy one to pull that into a Jupyter notebook or a Zeppelin notebook. And most APIs out there that you're dealing with machine learning are good with that. So if the only way I could get data into Pulsar and get it out was with these consumers, that's already pretty flexible. But we have a bunch of different connectors. You set up some YAML, and you've automatically got a source of data for yourself. Things like Debezium, Mongo, Cassandra, Kafka, Rabbit. You know, there's hundreds of them out there. We also support Kafka Connect ones. Same on the sync side. Get something in, send it out. Very nice way to do that. Support for all those different protocols we mentioned. We mentioned all these other ones. We'll get into functions. Those are really important if you want to do machine learning. That's how I could do it as events come in. Certainly I could have my machine learning as a source or a sink, or done in a processing engine, or done by anyone using any of those SDKs to send data in or out, and do that as part of a pipeline. But functions are nice as they're triggered by events. So think of this as your own AWS Lambda. We mentioned support for Kafka, support for MQTT, support for Rabbit. What's nice is this isn't a bolt-on. This isn't a sidecar. It's not an add-on. It's not some kind of, half-done translation layer. It is a full implementation at the same level of completeness that Pulsar uses for its own protocol. So it's not something you got to think of, well, how well is it supported? It is the same kind of protocol handler, proxy if it's there, and support for those native libraries. And what's nice is you can mix and match with no problems. So Rabbit sends a message in, Pulsar can consume it, so can Rabbit, so can MQTT, so can Kafka, REST, WebSockets, any consumer. It doesn't matter. Once you get it into Pulsar, it's in a regular topic, it doesn't matter. It's not in a special area. It's not in some format that no one else can get to. This is great. I could take my existing Rabbit apps, point them to Pulsar, and now that the data is available for everybody. Take your on-premise data, get it into Pulsar. Now it can be used and consumed by apps running in your cloud. So you could use it as a way to get your data from existing systems to machine learning, or use machine learning as part of a flow for those existing legacy apps without changing libraries, without changing protocols. Point to another server, or change your DNS entry and just point to Pulsar. No one has to know. Great way to do that. Very extensible, very easy. We mentioned those different sources. One is, say, Delta Lake. You might have a lot of data there. You might want to get data to your lakehouse. So Pulsar can get that data in. Maybe it's from Rabbit, wherever it's from. Get it into Pulsar. Maybe we run some ML functions on it. Get it into a topic ready to sync. And that'll automatically sync for you with no code to Hootie, Iceberg, or Delta Lake, or to just an S3 bucket or wherever you want to send it. Pulsar SQL lets you do Presto Trino, again, what data is in those topics. Again, we said we can keep that data forever. So this might be a good way for you to access data for your machine learning if you're doing Presto or Trino from there. And it doesn't matter where it's stored, whether it's in the Bookkeeper bookies or in our tiered storage. So we can subscribe to data. Again, this is a great way for your machine learning apps to find out when new events arrive and maybe trigger a classification or a training or retraining. And makes it very easy to do this. Filtering routing gives you a lot of power on how you execute these things. And again, we went through some of this before. Here's the main thing of the day, functions. And you could do a lot of different things in here. It's limited to what kind of data makes sense to send into something like Pulsar. We generally don't have images coming into Pulsar. Can we support binary data? Can we support large files? We can. Usually in a messaging or event system, you want sub-megabyte textual type of data. But, you know, your use case may differ. I do have some people doing some interesting stuff on binary data, but that's not typical. Typical, and why these specific models are mentioned here, because I've seen these, use some of them. NLP, I'll show you today. Visual question and answer, sentiment, text classification, content-based. Looking at time series data. Time series and Pulsar are perfect together. Predictive maintenance on things like sensors. These are perfect use cases for Pulsar functions. You just care about the business logic. This is nice. I don't have to know about Pulsar. I don't have to write any boilerplate code on how do I get, those events in or out. The Pulsar functions handle all that for you. And it can run different places. Again, deciding on who deploys it, they decide how that's going to run. Is it a thread, a process? Is it going to be in its own Kubernetes pods? You don't need for any other framework, and scaling can happen automatically for you. Now, you could also use this as part of an event-based microservice. So things can communicate through Pulsar. There's your way you communicate between microservices. And anywhere in this chain, you can easily have your machine learning functions. Now, to make things easier to knit together some of these complex applications, there's Function Mesh, open source system out there that makes it easy if you build an app and can declaratively connect things like functions and sources and sinks together. So you can have pipelines that are very easy to deploy out to Kubernetes. Pretty straightforward, actually. Now, why might we want to do that? Very easy to maintain and test. You're not writing too much code. You're most likely using existing machine learning libraries. The Pulsar code is very minimal. We do that for you. We keep things decoupled from each other because they only communicate via messages, and those can change. You can deploy them individually in different places, and Pulsar will figure out where they are and connect them. You know, one person, a couple of people can develop these very easily. Having a message bus that handles any kind of messaging pattern is awesome for wherever you want to deploy these. And you've got a lot of options how you send these out and support for different languages. What's nice with Pulsar is built-in back pressure. So when I'm writing an app, I have ways to handle it if things are, slowing down or I can't handle the performance. Very unlikely, but if you want a really small cluster, and you could decide what happens if I can't send my message. Do I wait? Do I do it asynchronously? There's a lot of options out there for you. Common use case I have is lots of topics come into a function. What's nice is it's not limited to one. You can have as many as you need and change them dynamically, which is a great feature there without redeploying or restarting or stopping. I can automatically connect to a log topic. So in case you don't want your logs just in a file somewhere and then maybe got to read them and process them, I can send it to a topic and can have Pulsar handle those log issues or metadata or whatever, auditing, whatever you have in there. And then by default, it can automatically go to a topic you subscribe, or it can route dynamically on the fly and actually create topics on the fly if you allow that. That's an option for your administrator. So we got this serverless event framework, similar to your own open source Lambda that you run anywhere. Pulsar is your message bus. So you've got this scalable way that you never have to worry about losing messages or crashing. And you can, if you don't want to have any other servers, the function runtime can just run with the brokers if you want. And things like Java and Pulsar, Python and Go are supported, with more coming, including SQL. Very easy to do. Assign a couple of topics or just one. Like say you write a generic sentiment analysis one. I could just apply, as I add new topics, I could just point them to that function. And in that metadata, remember those properties, I could decide, tell you where I want it to go. And they can apply that to that topic on the fly. Or create that new topic if it doesn't exist. Pretty easy there. This is an example of using the native Java function library to do that. No mention of Pulsar, no inclusion of Pulsar libraries. If you deploy this, this will work. This is saying string comes in, string comes out, and whatever input and output you define is where that's going to go to. Very easy. If you want a little more power, use the Pulsar SDK, and that'll give you access to this context. The context will let me build new messages, get access to a cache data, logs, some other cool stuff there. This is an example of a Python NLP function. Again, using the SDK. I define a class. I set this process coming up. Context gives me things like, if what data is coming in, access to logs, send the data, return it. It's just going to go to the defined output topic. Deploying a function is really easy. I can do that with the command line interface to the REST API, or using a cloud interface if you have something like Stream Native or one of the other cloud providers. And I just send it for Java, just send that jar, give it a name, give it all the topics I want, name it, and it's ready to go. Data comes in, gets sent to my function, comes out into a new topic, and then my apps could read it. Routing, enrichment of data, conversion. This is where I often take some rough data I'm getting out there and convert it into a standardized schema while I'm doing some maybe updates, enrich this with maybe some lookup data. Here I can run machine learning Usually things like classification, you don't want to run something too massive, as I have events constantly coming in. Again, depending on the size of your workloads, size of your servers, go for it as big as you want to go. If you want a giant, long machine learning process, just throw enough power at it. Parse your data, split it, convert it, whatever you want to do there. Pretty straightforward here. As you can see here, even in Python, I get that context. I can get the logger. I can get access to message IDs. Maybe I want to store that ID when I process things. So if I need to go back later, I have that point in time. It's up to you. Support for lots of different libraries and frameworks, because in the real world, you're building real-time apps. You're not going to do everything with just Pulsar. I might have Spring and Pinot and Flink and Spark, Scilla, lots of options out there. Let's show you a demo. Hopefully things didn't crash while we're running. So on one side, I've got Apache NiFi. It is consuming some real-time transit data from a couple different systems for where I am here in sunny New Jersey. So these are a couple of different systems. I have these on multiple topics. The data gets sent into Pulsar. That triggers a function I have out there written in Java. Run some OpenNLP to figure out location data from the text of traffic issues or transit issues. And then I put it into a cleaned up topic. Flink can do it. I could grab it with WebSockets and show that in a display. Let's see if everything's still running. I've been talking a while. It might have crashed in there. Might have to restart something. We'll see. It's the magic of live demos. This is the code to do my transit function. I'll go into it right now to give you an idea. So what happens is it triggers this transit function like we saw in that simple example. Here I've got raw byte data coming in, and I'm going to use the Pulsar context. I'm going to send it to a default output topic unless it's a certain type of data I want it to go somewhere else. So here is, I run my NLP. I see what type of data it is. If I get a location, I'm going to add that as metadata. And I'm also going to add that to the data in a field. Here I'm going to get a JSON schema from that class and send that to a new topic that I defined based on what type of data it is. Again, I could do that on the fly. Really nice. Do some logging if I want, if that's enabled. And then all the data I'm sending out there, I'm going to, regardless of which type of data it is, I'm going to send it to a topic that is joined for all those different 4 sources of data. And that's with this JSON schema, again, adding that location from the NLP. NLP server is pretty straightforward. Get my tokenizer. Take a look for names within that data. Put it in a string. Add that to the system. And we're ready to go. So we have that data coming in. Let me get a couple of sources of data coming. So I've got the current status of buses, rails, and light rails near me. And I'm also going to grab some of this Transcom data. Transcom is an agency that is a super group of 3 different states here in the East Coast of the United States. A bunch of different transportation and public safety agencies put all their real-time data into one feed. So you can imagine there's a lot of data in there. So which is nice to see when you're doing demos and to see what's going on. If you look here, I've got a backload of a lot of data here, 275,000 rows. I don't know if I want to send all that into my laptop, as that's a lot of data. And this is all this cluster, NiFi, everything's running on one laptop. So let's see how much data that is. This is a simple WebSocket HTML page I wrote. Again, that source code's published out there. So this is getting all the events via Pulsar. And this is just a nice feature of Pulsar, is that I can read any of that data from those. Now, if we stop and look at this location column, that's the one created by that NLP. And if we take a look at that function, you could see that we've run a number of runs of that function. We've already run 600. As you can see, that's coming through the system there pretty quickly. I've also put these on a map. Pretty easy to do here. And it's just a nice way to be able to see this data live. This is using that WebSocket connector that's built into Pulsar. I don't have to write something that translates it from a Pulsar consume to something that a web page can read. So I can deploy this as a web app or as a mobile phone app. And again, with ML in the middle. Or on the other end of this, I could have machine learning reading this via either Pulsar, Kafka, MQTT, WebSockets, REST, Trino, Pinot, Spark, Flink, whatever your system uses there. Pretty straightforward there. I should probably stop that at some point before I get a million messages. If you want to learn more, I've documented this at DZone as part of their Enterprise AI report, and it shows you how you can build an event-driven platform for running machine learning and deep learning. There is a full book on Pulsar that my friend David wrote. This is a long, very thorough book. If you read this book, you can instantly become a very high-paid Pulsar consultant. This book has everything in it. The full book is available for free. Download the PDF today. If you want to do a little more, there's some free training on demand available. You get your own little Dockerized cluster there to play with. And I have an app example out there for building edge apps with some ML with Pulsar, and you can check that out at our blog. I've got links to some other functions I've done to give you an idea. How do I write a Pulsar function? How do I add a little machine learning in there? Scan away, get some more information, build your own apps. Connect with me. I'm always on LinkedIn. I'm on Twitter until they shut it down, I guess, or it gets too weird. And definitely check me out on GitHub. I've got hundreds of repos, lots of examples out there. Hope you enjoy the event. It's been nice talking to you. Definitely reach out. Thanks a lot.